In this episode, we're setting up our blueprint infrastructure where the player can move while casting, and we're setting up our game's third gameplay ability, Fireball. Let's get to it. Hey guys, welcome to today's episode, and again, we've got kind of a monster episode today, but I've got to say that this is the most fun I've had yet since starting to develop this game. In episode 27, we covered how to animate the player character with the player's character standing still by using a state machine that we built from the ground up. And in today's episode, we cover the other half of that, how to spellcast, how to use gameplay abilities while the player is moving. And between these two episodes, episode 27 and today's, you're going to know how to animate virtually any kind of gameplay ability. But the challenge that we're covering today is that blending multiple animations for different parts of the body, so for example, a different animation for the upper part of the body compared to locomotion for the lower half, that works fundamentally different than just state machines and animation sequences. We have to use a new kind of animation tool we haven't yet used in this series called an Anim Montage, and then we end up blending that Anim Montage via what's called a slot into our final pose in the Anim graph. So the first half of this episode, it's all about setting up that fireball montage and then blending it in with the rest of our animations. And then we're going to end up having to create a fireball actor because it's going to do something once it leaves the player's hand. And as is typical for these episodes, the second half is going to be all about troubleshooting and optimization. One thing to add, it's the first time in this series that we're getting to use Unreal Engine 5 physics. Just tipping our toes in the water for now, but it's a start. In regard to our gameplay abilities episode that we started in episode 26, this episode is once again focused on the upper right quadrant and also on the bottom left quadrant. And by the way, if you want to start with all the gameplay ability episodes that we have in this series from the ground up, start with episode 23 and work your way up. And I've got a playlist on the channel exactly for that. And very similar to our flamethrower episode, episode 27, we're using just one animation from Mixamo, but we do have two sounds from Zapsplat. If you followed along in episode 27, you're already going to have one of those sounds. And as always, you can find links to this content in the spreadsheet that's linked in the description below. And finally, here are our key concepts for today. I think what I love about this episode is that we are combining more things into this one episode, basically drawing from maybe a dozen of our previous episodes. We are doing Niagara, we're doing sounds, animations, aiming, basically everything you can think of, and some new stuff packed into this one episode. So let's get to it. So first up, we got to get the animation we need from Mixamo, and that's going to be our standing one-hand magic attack 02 right here. And if you're wondering how I got this mannequin loaded into Mixamo ready to animate, just check out episode 25. That episode covers everything you need to get Mixamo animations into UE5 and mapped over to your mannequin. But since we've already covered it in detail, I'm not going to go through my entire process. I just want to go through exactly what settings you need to set to get the animation the way I'm using for this episode. So the first thing to note is it looks like he's pitching a ball really slowly, and I want this to be thrown like he means it. So we're going to push this to overdrive. We're going to move it up all the way to 95. That's looking a little bit more intense. And then the next thing is we need to trim this animation. So it's going to start a little bit later, and it's going to go till about frame 60. So right about there. And the reason I'm doing that is because it's going to blend into our other animations, so we don't need it quite as long. And then with those settings, just download and follow the process in episode 25. So in episode 27, we began by creating this brand new state machine, spellcasting standing still. And this works great for standing still animations. But I want the player to also be able to move around while casting certain spells, using certain abilities. And so the problem is, anytime we're using animation sequences in the state machines, it's basically just doing the full body. There's not a good way that I know of, at least, of animating just a part of the body just using state machines. And so the way we're going to solve that problem for this fireball spell is we're going to use what are called animation slots. And it says that as you create more complex animation behavior for your characters, it may be necessary to create proxy areas in your animation blueprint where we can insert one-off animations. And these are mainly used in animation montages. And you'll see below in the overview here, it basically has a diagram illustrating how this is going to work. And so back in our anim graph, I'll go back to that. You might have wondered back in episode 27, like, what the heck is this thing, this slot default slot? And what that's doing is it's activating all animations that are using the default slot. And so what we're going to end up doing is we're going to specifically use slot upper body for the montage that we're going to create for that fireball animation. And so what that's going to do is it's going to get our montage animation, But because of this layered blend per bone, it's only going to blend at whatever bone we specify and up. So it's going to be actually spine 3 and up. And I'll explain why we're sticking with spine 3 in this case. And if this doesn't make sense at this point, I totally understand. This is one of the more confusing areas of animation, but we're going to get into it. I think you're going to understand it as we go step by step. So we're going to start by going to the content drawer, content, and we're going to go to the folder that stores the animation that we just brought in. So that for me is under Mani, Mixamo, and I named the animation one hand side throw. And so now what we're going to do to make this animation sequence also into an Anim montage, we can right click on it, and then under create, we could say create Anim montage. And I'll call it exactly the same thing, one hand side throw underscore montage. And so now before we even set up the slot or the integration with our animation blueprint, all of that stuff, let's just get a simple test of this montage up and running as fast as possible. And so I'm going to go back into our third person character blueprint because that's where this is going to get generated. And mine's under my core folder here. And in episode 26, we started our gameplay ability system, and I'm just going to copy everything we did from our flamethrower episode here, and I'm going to paste it down below because this is going to be activated by keyboard 3. And because this fire ability is not going to be a channeled ability, it's going to be single cast for our fireball. I'll select that. And just for now, I'm going to deactivate the Niagara system. So no Niagara system for this one. And also because this is a single cast, we don't need to deactivate the ability. It's going to auto deactivate. So I'll delete this out, compile and save. So now I've got to go into my gameplay ability fire blueprint. So that's under blueprints, gameplay abilities, gameplay ability fire. And we set this up initially in episode 26. So back in our event graph, we have to set up what's going to happen when we activate our ability. So I got to come up here, activate fire abilities, single cast. And from this pin, single cast, we are going to play montage. And we get this big node with a little clock icon on the right hand side. This simply indicates it plays across time, just like a retriggerable delay here. It does something across time. So our in-skeletal mesh component, that's going to be attached to our third person character reference mesh. So I can copy this and then I can move it over here and I can connect this up. In the montage to play, very simple, one-handed side throw montage. The last thing I'm going to do is I'm going to say, okay, when this montage is completed, that's when it's going to end the ability. So for that, what I'm going to do is I'm going to get a reference to our animation blueprint. And then from there, I can call the end spell restore event, anim notify actually. Uncompleted, connect that up. And what this is doing, and again, this is something we set up in episode 27, I think. So if I go to my event graph, come down here. So that's all that's doing is setting movement mode back to normal, back to walking, and destroying the gameplay ability actor. Last thing I'm going to do here, just because I think we're going to need it, I'm going to move some up and I'm going to move all of these down. We're going to create some space. And I think we're going to end up collapsing a lot of this stuff to functions pretty soon. But for the time being, just create some space right here. Compile, save. So let's test this out. All right, so I spam 3 and there we go. So my body is moving and the problem is I can move my body, but my legs look like they're surfing over the dirt as I'm doing this. And so that's our next step, right? We want to animate just above the waist, but we want to keep the locomotion going below the waist. So this is where the slot functionality that I mentioned earlier is going to come in. So we're specifically going to use a slot for the montage that's the upper body only. So for that, I've got to go back to the montage. So content drawer, and it's under characters, mannequins, animation, Mani, Mixamo, one-handed side throw. I'll just pause it down here. So right here, we see the montage is using by default the default slot, which would make sense. So we got to switch this. But I found that unless we do this in a precise way, and I'm going to show you the steps to do it, it's very finicky. I was only able to get this working properly if I switched it in precisely the set of steps that I'm going to show you now. So the first thing is next to the default group montage here, select this drop down and go to new slot and choose upper body. And then next to the top one that says default slot. So we're going to select that and say slot name, select upper body. And it then breaks the animation montage and we get this yellow exclamation point right here. And now this is where it gets weird. For the second one here, go to slot and say preview slot. And now the animation's showing up properly again. And now we got to switch the preview to the first one. So now go to the first one and say preview slot. And last but not least, go to the second one. Only after this one's set to preview, then we got to go to the second one here and say delete slot. And that was the complicated series of steps I needed to execute to get the slot properly mapped to the Anim montage. All right, so now we got to blend this Anim montage with the rest of animation going on with our character. And so that's happening back in our Anim graph. So we got to go into our animation blueprint, into our anim graph. So what we're about to do, this is also kind of weird, a little bit confusing. And so I'll try to explain it as best I can. So what we're going to do is we're going to take everything coming out of our main states, and that's everything that we set up in episode 27, and also what was already in the blueprint by default. But we're going to take all of this and we're going to save it to a new pose, very similar to what we did in episode 27. And then that's going to be our overall pose. But that pose is going to be blended in with whatever's going on with our upper body. So what I want you to do is I want you to disconnect this pin right here and move everything here down. And so we're going to take our pose here, copy that, paste it below, and then connect this up. But this spellcasting standing still, I'm going to rename this, and this is going to be called our overall pose. And by the way, if you just want to pull one of these in by yourself, you would just say new save cached pose, and that's it right there. It does the same thing. So now that we're saving our overall pose here, we can now use our cached pose, use cache pose overall pose. And this I'm going to connect right up here to the default slot. But now here's the weird thing. I'm going to take both of these, I'm going to copy and paste them right below. And then here, this is where I'm going to switch the slot. So instead of the default slot, I'm going to use just our upper body here. So this is going to get our upper body animations, basically whatever Anim Montages are playing in that slot. But then we have to blend these two, right? Because we still have to blend the overall pose here. So for that, I'm going to drag out a pin. I'm going to do a layered blend per bone. And I'll connect this one up here. Compile and save. So far so good. You should see 2 execution pins basically running into that layered blend per bone. But now we got to tell it where to blend. So if I select that node, I've got to expand the layer setup here, and under index 0, branch filters, 0 array elements, we're going to add 1, and our index 0 is going to be spine 03. And the blend depth is going to be 1. Now the way I think this works, and I could have it wrong, is that a blend depth goes upwards, kind of away from the pelvis, away from the root bone, whereas a blend depth of -1 would blend downward, like towards the pelvis. The last thing here is we got to set mesh space rotation to true. Now you might be wondering why I'm setting this to blend at spine 03. But here's the idea I have. So if we set it to spine 01, so all the way basically at our pelvis, then we're completely subjected to whatever the montage is doing from that point upward. But what I'm thinking is if I set it to 03, then the Anim montage still plays in the upper part of the body and all the arms, obviously. But for those first 2 spine bones, that gives me some control in state machines to be able to point the character in a particular direction. So we're still going to have some aiming in terms of how the animation will change a little bit, like aimed upwards or downwards, based on what's going to be going on in the state machine. And it's going to be all driven from spine 01 and spine 02, because everything above that is going to be the Anim montage overriding it completely. So what this layered blend per bone is doing is it's basically saying, okay, if any animation data is received in slot upper body here, then automatically override for that slot everything above spine 03. And the reason it's automatically overriding and not really blending is that this blend weights is set to 1. If this was set to 0.5, then it would be half this and half that. But we don't want to do that. We want all upper body, the montage, and then all lower body, the regular overall pose. So now we're going to test this. So compile and save. Let's give it a whirl. All right, moment of truth. 3. Yeah, and look at my legs. My legs are still moving. And I'm able to turn. If I'm standing still, yep, it's only blending on that 3rd spine bone and above. So far, so good. And so now let's set up our Niagara system. And what we're going to use as a baseline is our flamethrower that we set up in episode 27. And if you just want to check out that part of the episode, it's from minutes 7 to 16 in the episode. We basically take from our starter content, there's a cascade particle system for fire. We need to convert that into Niagara. I show you the changes that are needed to change it into the flamethrower. And that's what we're going to leverage now for making this fireball. So I'm going to go back to our Niagara Gameplay Abilities Fire folder. We're going to create a new folder for Fireball. And then from within the Flamethrower folder, I'm basically going to right click on this. We're going to duplicate, and this is going to be Fireball base. And then I can just move it into the Fireball folder just like that. Move here. I'll go into that folder, and we'll double click to go into our Fireball. And as we can see by default, it's a flamethrower. So I need to update a number of things in each of the emitters. So we're going to start with our initialized particle here. We've got to change our lifetime. So instead of 0.7 to 1.0, it's going to be a lot shorter. So 0.3 to 0.4. And I'm going to do that for all 3 emitters. 0.3, 0.4, and the same for our distortion. And then also for initialize particle, but just the first two emitters for this setting. The sprite rotation mode, instead of unset, we're going to set this to direct normalized angle. And this is going to give it a much more rounded feel. Same thing with this one, sprite rotation mode, direct normalized angle. You see it already there, it's kind of spinning in a variety of different directions. For our third emitter here, I'll do the same thing, initialize particle, sprite rotation mode, direct normalized angle, and you see it actually defaults to 0.8 to 1.2. That's exactly what we want here. Alright, so now we need to update all the add velocity nodes. So instead of 350, this is going to be negative 200, and this one's going to be negative 150, because the fire is going to be backwards, right? The fireball is moving forward, but the actual flames coming out of that fireball are moving backwards. And then the Z is going to be a little bit randomized, negative 5 and 5. And our second emitter is going to be exactly the same, so negative 200 to negative 150, and Z negative 5 to 5. So our third emitter is going to be a little bit different, the distortion effect. So this is still going to be negative 150 and then negative 200 here. But for the Z, it's going to rise up a little bit faster again. So it's going to be 0 to 10. And then the other thing we're updating for all emitters is this acceleration force. So it's going to be X negative 20, so speeding up with time backwards, and then Z of 0. Same thing for the other two emitters. So negative 20, 0, and then this one as well, negative 20 and 0. And just like I mentioned at the end of episode 27, the light renderer here, very expensive from a performance standpoint. So I'm going to uncheck that. And for our fireball, it's actually going to have a fireball actor, and we're going to put a point light directly inside it. So that's going to be what emanates light. And the last thing, I'm actually going to disable collision on every single emitter. And the reason for that is, well, number one, it's going to improve performance. But number two, the collision is actually going to be handled with a capsule that surrounds the fireball. And if you have any other ideas here to make the fireball look even better, I'm all ears, so please post them in the comments below. So now we need to set up this fireball to be spawned. And here's what I'm thinking. So when the montage begins playing, that's when the actual fireball particles are going to start spawning. And then when the montage hits its apex, like it hits its point right about here where it's about to be released, that's when the fireball is actually going to fly off the player's hand. And so to make this happen, we got to start by going first into our gameplay ability fire into the event graph. And right next to play montage here, I'm just going to move this down because as soon as it starts playing, that's when we're going to spawn the Niagara system. And so what I'm going to do is I'm going to zoom out and I'm going to select the spawn system attached here, and I can paste it below. And this one is actually the light that we set up in episode 23, the torchlight effect. And for this, I definitely want the Niagara system when it's created to auto destroy as soon as the particles stop spawning. I'm also going to change the location to be 000. And so now let's compile and save, and there's one more thing we got to do to test this. So back in our third person character, we unselected the primary Niagara system. So now let's search for our fireball, select that, and now compile and save our third person character. We are ready to test. All right, so now let's test it out. 3, and we get our flame, we get our fireball, but it's still attached to our hand. It's not released yet, it's not going anywhere yet. So how do we make it actually move in a particular direction, and specifically the direction that we're aiming? And so for that, we're going to create a brand new actor and blueprint specifically for our fireball. So back in our content drawer, I'm going to navigate over to blueprints, and then here I'm going to create a new folder titled Spawned from Abilities. And in that folder, I'm going to right click, I'm going to create a new blueprint class. And before you select actor, we're actually going to create this from pawn. And see if you can guess why we're going to create it from pawn. It's not going to be relevant this episode, but it is a spoiler for the future. And we're going to title this BP underscore fireball. And then I can double click to go into that. And now the very first thing we're going to do in this actor is we're going to add a collision capsule. So we could search for collision, and we're going to add capsule collision. And I'll just title it collision capsule. And by default, that half height and that radius, totally fine. We can leave that as is. But there's a few settings in our collision capsule details here that we want to change. And the first one is hidden in-game, and uncheck that. And the reason is that when we actually cast this fireball, at least to start, I want to see in which direction the collision capsule is oriented, because we got to make sure that it's actually pointed in the direction that the fireball is aiming. And then if I scroll down, a couple other settings we need to change. So under collision here and collision presets, I'm going to change this to block all. And the reason it's set to block all is because, well, we want that fireball to be able to hit anything in our game, right? But then I'm going to expand it, and instead of block all, I'm going to switch this to custom because I want to change the object type here to pawn. And I'm not sure exactly what this tries, but it says enum indicating what type of object this should be considered as when it moves. And I specifically want to consider this a pawn as it moves. Now, you heard me say all the way in the beginning of this episode, this is the first time that we're simulating physics. And so for this capsule collision component, Simulate physics, checked. And the last thing, can characters step up on? No, we don't want our character to be able to step up onto the fireball. Although that would be interesting, kind of riding a fireball, but no, we're not going to do that. So the next thing we're going to set up is we're going to add a point light directly in the middle of the collision capsule, and that's going to be the light that emanates from our fireball. So I could search for point light here. Make sure it's underneath your capsule collision, and I'll just title this fireball light. And then for the light color itself, I'm going to change this to be more like an orangey red, like something around there should be good. Okay, and we'll keep the settings as is. If we need to adjust this in the future, we can. And potentially even adjust it based on the intensity of the fireball. Next, we're going to set up two variables on our fireball. So under variables, plus sign, the first one's going to be intensity. And this, of course, is going to be a float. And the next one, hit plus again, and this one's going to be direction. So what direction is the fireball moving? And that's going to be a vector. And both of these are going to be set to instance editable and exposed on spawn. Because as soon as that fireball is spawned, we want to be able to pass in the data that's going to tell it, okay, here's what we're going to do. And so now, before I even cast the fireball, let's just get a simple test of the fireball up and running in our world. And so to do that, to simulate what it's going to look like, I'm just going to add a sphere component. So I can search for sphere and make sure to put that under collision capsule here. And we've also got to scale it down because it's somewhat huge as is. So scale it down to about 0.2. That looks good. Compile and save. And on begin play, we want this to actually move. So let's navigate over to the event graph. And I can drag in a reference to our capsule collision, which now has physics enabled. And we can add impulse, if I could spell correctly. And it says add an impulse to a single rigid body. Good for a one-time instantaneous burst. Perfect for begin play. And connect it up right there. So now what is our impulse actually going to be? So let's make some space here. And I'm going to drag in a reference to intensity and drag in a reference to direction. And this is where it makes sense to change our default values. So intensity, I'm going to set it to be, let's do 1000. And direction, let's just make Y1 so it just moves sideways. And then these are going to be multiplied. So I'm just going to do a multiply of our vector. Actually, I got to connect it here. And then this is going to be connected there. And then that's going to be connected to impulse. And just to make sure that it's mass, so the mass of this object has no effect, let's select velocity change. So compile and save, and now let's test this out by dragging it into the world. So we'll just drag it right over there, move it up a little bit, and play. So there's our ball, right? It just went bouncing off, and I think I can play soccer. Yep, pretty much. We got a soccer ball. We're good to go. No, just kidding. But so far, so good. It is moving. It's got physics. We just got to disable gravity, right? So I can go over to our collision capsule, and if I scroll down a little bit, enable gravity. Uncheck that. Compile, save. Let's test again. So there's our ball. I see it flying. Oh, it just collided, and now it's flying off into the wild blue yonder. I don't think we'll see that ball again. Back in our gameplay ability fire. So right after we play the montage, let's detach the spawn system attach because this is going to be distracting for now. We will come back to it later, but let's just get our fireball up and running. And next we have to go into the montage because in the montage, that's when the fireball is actually going to be released from the player's hand. So let's navigate to our content drawer. We'll navigate back to content and then characters, mannequins, animations, Manny, Mixamo, and we'll go into that. And I'll just pause it. So we have to assess where in the montage, like at what point is that fireball actor going to be created and released from the player's hand. And what I found to have the best effect is right about here. So kind of at the apex swing of the player's arm. And so how do we generate an event at a point on a montage? Well, it's the same way as an animation sequence. So under notifies here, I can just right click and I can add a notify. And actually, we don't need to create a new notify because we already have one for this from episode 27. So if I go to skeleton notifies and I search for activate main ability effect, and there it is. And so what is this activate main ability effect actually going to do? So if we go back to our animation blueprint in the event graph, if you remember, we created this anim notify activate main ability effect event. And then what that does is it checks whether or not there's something directly in front of the player. And then if there is something directly in front of the player, it basically says deactivate the ability. But otherwise, it activates the primary Niagara system here. And actually, by the end of this episode, we're going to change the name of this event just to be a little bit more specific. Because in this case, in the fireball's case, the Niagara system's already going to be activated because it activates the moment the player's animation starts. But now let's set up what happens when this event gets called. So if I go back to gameplay ability fire, and that's happening a little bit further down, this activate primary fire Niagara system. And this is for a single cast ability, so we have to hook up something here. And this is where we're going to spawn actor from class. And what class is it going to be? Well, it's going to be our fireball, right? BP fireball. And we need to give it a spawn transform. So I'm just going to get our third person character reference. And then from there, I'm going to get the actor transform. And I can hook that up just like this. Now, for the simplest possible test, let's not worry about camera direction or anything like that. Let's just do Y1 so it always aims in the same direction. And we'll give it an intensity of 1000. And that's going to determine the force by which the fireball is thrown. And the last thing is, for this collision handling override, make sure to change this to always spawn ignore collisions. Because as it stands, it's always going to be colliding with the player because we're spawning it right on the actor. Compile and save. Let's give this a test. All right, so there's our fireball actor, and now not doing anything because no gravity and 0, 0, 0 direction and intensity. But now let's give it a test. So 3, and yep, so it's always going in the same direction, but we see it actually generating right from our character there. And so far, so good. So now we actually have to figure out what direction we're shooting the fireball in, right? And for that, we're going to get our character's rotation. And basically, we're going to orient the direction of the fireball to be the forward vector of our character's rotation. So to do that, I'm first going to add a reroute node here. I'm going to move this out a little bit. We're going to get a reference to our third person character, drag that out, and get actor rotation. And from the get actor rotation, I'm going to get the forward vector. So that's the forward direction of the rotation. And I can hook that up here. The other thing I'm going to do is, instead of spawning the transform from the actor transform, which is like right dead center of our character, instead I want to get the transform of the socket, the hand socket that we set up all the way back in episode 23. I'm going to drag this down, and first I've got to get a reference to the mesh, so get mesh. And then from the mesh I can get a reference to get socket transform. And I'll delete out get actor transform. We don't need that. And this is going to be the hand underscore R socket. And again, if you don't know how to set up sockets, check out episode 23. I go through it. It only takes about a minute to set up. All right, let's compile, save, one more test. All right, so now we should be seeing that the fireball gets released from the hand and it releases forward relative to our player's actual rotation here. So there we go. 1, 2, 3. Yep. So far, so good, right? But the problem is, what if I want to aim upwards? Like, what if there's an upwards target or something right below the player and I need to aim downwards? So back in episode 28, we figured out how to aim based on the camera angle using the get control rotation and comparing that to our character's actual world rotation. And we ended up creating this macro here for rotation of camera on our Anim blueprint. But this time, it's actually a lot easier than this because we don't need to compare these two things because we're not adjusting the player's bones based on that rotation. So instead, I'm just going to get the player controller and the get control rotation. If I go back over to our gameplay ability fire, so instead of setting the direction like this, I'm going to drag this out. I'm going to delete out both of these, paste those in, the player controller and get control rotation. And then from the get control rotation, all we need to do is get the forward vector. And then I can connect this up. All right, one more test, compile and save. All right, aiming upward. Yeah, there we go. So far, so good. You know, it looks like I'm playing baseball with one of the classic sidearm pitchers like Dennis Eckersley or Randy Johnson. But there's still a couple of issues with this that I see. So number one is that, you know, it doesn't adjust the player's skeleton at all. It's just pitching to the side here or this side here, and it doesn't look natural, right? Because the player's skeleton should orient somewhat to the direction that they're pitching. And the second one is the player might not want to aim with their camera. They might not always want to aim in that particular direction. So let's solve the second issue first. It's an easy fix because we set this up with the channeled spell aim in episode 28, and we're going to use right click to determine whether or not the player wants to aim with the spell. So back in our gameplay ability fire blueprint, I'm going to expand this a little bit. I've got to create some space here, so I'm going to move this up. Same with our reroute node, move that up. And the reason we needed to create space is because we need to have a branch node, and the branch node is whether or not the player's right mouse button is held down. So I can get another reference to our third person character. Get third person character reference. And if you recall, in episode 28, we just created a Boolean variable that was titled right mouse button. So get right mouse button active. And then if that is active, that's what's going to determine aiming based on the camera rotation. So I'll connect this up to a branch node, connect this up here, and connect this up there. And so if it is active, that's when it's going to get the forward vector of our control rotation. But if it's not active, what do we want to have happen? So I can take spawn actor BP fireball, copy that, move that down here, and that's when we're just going to get the actor rotation again. So get actor rotation, and we've got to get the forward vector. Get forward vector, and that's going to be hooked up to direction right here. And once again, our socket transform is going to be our spawn transform. Compile and save another test. All right, so now my right mouse button is not held down. So he's still pitching forward there. But then right mouse button held, there we go. Boom, boom, boom. Now I do see one more issue with this, because if I'm holding my right mouse button down and then I'm aimed backwards, he's pitching backwards. So why don't we just lock that in like a 60-degree angle? So maybe a 60-degree angle out from the player that he can pitch in any direction. But anything beyond that, it just reverts back to the normal. It reverts back to the straight ahead. So to address that, I'm going to make some more space out here. And what we need to do is we need to get the difference between our camera rotation, which is this get control rotation, and the actor rotation. And if the difference is greater than 60 degrees, then what I want to have happen is I want it to go this route, even if the player's right mouse button is held down. And so to get the difference, we first drag out a pin from get control rotation, and I'm going to get the delta rotator between these two things. And then I'll connect up the actor rotation. And now we don't need to get the difference for the entire rotator. I'm going to split this because what we really want is the Z here, because the Z is determining the left-right angle of our rotation. The player needs to be able to aim straight up in case there's an enemy or something that's straight up. So I'm not going to limit the ability to turn down, turn up. And this difference in Z, this could be negative or it could be positive, depending on whatever angle the player is facing. And so what I'm going to do is I'm going to get the absolute value of this, absolute float. And so long as that absolute value is less than 60, so as long as it's less than 60 degrees, then the player can actually aim with the right mouse button. So if that value is true, so I'll connect up this branch. If it's true, it's going to go right here and it's going to do its thing with the right mouse button. But if it's false, it's going to revert back to aiming straight ahead. So basically, this is getting the world rotation of the way our camera is facing. This is the world rotation of the way our actor, our character is facing. And if that difference is greater than 60 degrees from left to right, then it's going to go back and it's just going to aim straight forward. Compile, save, let's test this out. All right, so I'm holding my right mouse button down and I'm aiming, and yep, it still pitches forward there. But if I tilt backwards, yep, I can't tilt backwards. I cannot aim backwards. It has to be in that 60-degree arc. I can aim straight up though, so that's looking good. So the last issue I want to solve relative to the camera aim is changing the direction that the character is facing, or at least the upper body of the character is facing, to be closer to where they're actually aiming. And if we go back into our animation blueprint, the Anim graph, so this right here is specifically looking at spine 03 and above. And like I mentioned before, the reason I set that is because now we're going to set spine 01 and spine 02 to be able to rotate a little bit depending on where the character needs to aim. But if you remember from episode 28, the flamethrower aim episode, we ended up rotating all 5 of our spine bones just a little bit, 15 degrees in any direction. And in this case, we're only going to rotate those 2, but it's still going to be locked to the 15 degrees. And the way we set that up was in the event graph. If we go all the way up, up, up in our event graph, so every single tick, it's doing this assess, adjust, aim. And that assess, adjust, aim function is assessing, okay, is the player standing still? And is the right mouse button active? And if that's true, then it gets the rotation of the camera, and it sets our spine rotation to be, well, our interp, so it smooths out the transition, but it moves the current spine rotation closer to where the rotation of the camera is pointing. And I was thinking to myself, since we're only moving the 2 spine bones, couldn't we set this so that it just always happens if the right mouse button is active, where it rotates in that direction? And then we don't even have to worry about whether or not spellcasting standing still is true. Because I think this will be universally applicable. Like if the player wants to look at something, it's going to give them that sense of presence. They hold the right mouse button down and the character kind of turns a little bit, not fully because it's 2/5 of the bones, but a little bit in that general direction. So what I'm going to do is I'm just going to delete out this and, delete out spellcasting standing still. Just going to move this closer, connect this up, compile and save. But then there's a second part of this, right? Because in our spellcasting standing still state machine that we set up in the flamethrower episode, if I just go into our channeled spell animation loop here, so we have each of these transform modify bone nodes, and that's changing the direction of the bone, the rotation of the bone, based on what we set in that function I just showed you. But in our case, we want to do it while the player's in a locomotion state. And we're specifically doing it for spine 01, spine 02, because it's going to have no effect from spine 03 up, because that's what's being overridden by the montage. So what I'm going to do is I'm going to select both of these nodes, and then we have to go into our locomotion state machine. And specifically for the idle and the walk run, we're going to do this for both. Double click into idle. And if you don't see this local to component in these 2 bones, IK and transform modify bone, so these come from episodes 23 and 24 when we did the torchlight effect with the right arm holding up. And that's okay. What you can do is just look for a local to component node. But I'm going to drag out some space, and then from that local to component node, or your 2 bone IK here if you're following along, that's when we're going to paste in our 2 nodes. So transform, modify bone, we can connect these up and connect this up here. And this one is just set to spine 01, and we're adding rotation to existing. And then this one is spine 02. It does the same exact thing. And I can copy those again. We're going to go back into our walk run because we also want the spine to rotate a little bit if the player's walking or running. We'll do the exact same thing. The last thing I'm going to do is I'm just going to add a comment, and I'm going to show you guys how fast I can type. You ready? There we go. There's my typing speed. So if right mouse button is held down, rotate spine in direction the camera is looking relative to the player. 2/5 rotation for 2 out of 5 spine bones. Now go back to locomotion. I'll go back to idle. I'm just going to add the same kind of comment. You know what I should start doing? I should start putting in the comments like what episode we actually covered the thing under. So then you can easily refer back to it. So this I'm going to say episode 30. Compile and save. All right, here's the test. When I hold my right mouse button down, does the character actually turn slightly in that direction? So right mouse button. Oh, look at that. And he bends upwards a little bit and bends downwards a little bit. Oh, that's neat. And so for spellcasting, yeah, so that works pretty well. Right mouse button held down, it's whatever directions he's aiming in. And it still doesn't look perfect like if he's aiming straight up, but at least he bends slightly in that direction. So it gives it that sense of, okay, he's actually responding to what the player's doing. So now that we got our aiming set up, all that's left is finishing the setup on our fireball actor. So let's get into that. So our first step is getting our collision capsule aligned with the direction that the fireball is actually moving in and keeping that aligned every single tick. And you might ask yourself, well, why every single tick? And you may have guessed this from earlier in the episode when we created this fireball, but the reason that I created it as a pawn is that at some point in this series in the future, we will be able to possess and steer this fireball. And so if we're going to be able to steer this fireball, then the collision capsule needs to change direction. It needs to always face the direction in which the fireball is actually moving. And it needs to do that every tick, otherwise it's not going to be an accurate representation of what the fireball is doing at any moment in time. And the way this is going to work is at the very end of each tick, we are going to set a variable that I'm calling previous location. And then at the beginning of the next tick, we're going to compare where the fireball actually is at the present moment in time compared to that previous location. And then we can get the direction between the two. So pretend at the end of the first tick, the fireball's here. And then at the beginning of the next tick, the fireball's here. So it's going to compare these 2 points, and then we're going to get a direction between them and align the capsule to face that direction. So first we have to create a new variable. So I'll come over here. This is going to be the previous location, and this is going to be a vector. And the way we're going to set that variable at the end of event tick is first we got to get our collision capsule. We have to get world location. And then from that, we can set the previous location. So I'll drag up a pin. And so now we have to do something very similar to what we did in episode 28. So the first thing is I'm going to make some space, drag this out, because this is going to be all the way at the end of event tick. And at the beginning of event tick, we have to first get our collision capsule. We have to get our world rotation. And this world rotation is going to be rotated towards something, so we can R-interp to, and that's going to smooth out the rotation change over time. And for our target, well, we got to get the look at rotation between those 2 points, right? So I can drag out a pin. I can do find look at rotation. And the 2 points, so the first one is going to be our previous location. And for our second one, that's going to be our collision capsule, its current world location. So get world location. And move these over and connect them up. And so what we're doing here is we're getting how our capsule is currently rotated, and we're changing that over some period of time to where it should be rotated. But unlike episode 28, where I made this change kind of slowly over time, here it's going to be very fast. So delta time 1, interp speed 1. And so from this, what is this doing? Well, it's going to set our capsule collision's current rotation. So set world rotation. And that's going to be connected from the event tick, and this is connected right up here. And then last but not least, we are getting our current location, and we're setting that as the previous location, because then this is going to be used next event tick. All right, so let's test this out. Compile and save. All right, so when I cast this, the rotation of the capsule should turn to face in whatever direction the fireball is actually moving in. Ready? So 3 and 3 and 3. And actually, it is rotating according to the fireball direction, you'll notice. But the problem is the capsule is facing sideways, right? It's not oriented so that the long way is the direction in which the fireball is moving. So we just got to make a simple change and we'll have that fixed. So the way we're going to fix this, and I have to make a little bit more room to make some space here. First, what I got to do is split this struck pin right here, because what we have to do is we have to add 90 degrees to the Y value. So I'm going to do plus and add 90. And so the question is, why the Y value? So if we go back to the viewport, you got to be in rotation mode to see this, but The green is the Y value, the second axis here. And that's the axis that's actually turning it on its side. So back in our event graph, I'm just going to split the struct pin for target. I'm going to connect this up directly. Y is going to be here with the plus 90 and Z right there. And I can also add some reroute nodes just for organization here. Compile, save, one more test. All right, here we go. 3, 3, 3. Oh, look at that. It looks like torpedoes being fired from a submarine or something like that. Yep, capsule's aligned in the appropriate direction. So now I'm just going to zoom out. I'm going to select all of this. Well, actually, I'm going to drag out event tick a little bit, select all of this, and we are going to collapse it to a function. And I'm going to right click, rename. It's going to be called align capsule component based on, I always capitalize the A, on movement. Compile and save. So now it's time to set up the attachment of our Niagara system to this BP fireball. So we got to go back into our gameplay ability fire, and I'm going to come up a little bit, come up back to our play montage here. So remember, what I want to do is I want to spawn the system immediately as soon as the montage begins. But then when it reaches its apex, that's when it's going to actually attach the system to the fireball, and that's what's going to throw it out of the player's hand. So immediately when the play montage begins, it's going to spawn the system attached right here. I'm just going to move this over a little bit. And so now I have to come back down to where we spawn our BP fireball. And from here, we're going to do something that we've never done before, which is we can take an existing component from one actor and we can then attach that to another actor, in this case, our BP fireball. So the way we're going to do that is drag out a pin. We're going to do attach component to component. Attach component to component. And what we're attaching is our Niagara System 1. And the question is, where are we attaching it to? Well, we're attaching it to the capsule component. So we got to get the capsule component and get collision capsule. There it is. And connect this here. And there's no socket we're attaching this to because it's not a skeleton. But for the location, yeah, we have to snap this to the target. And I'm going to copy these and I'm going to paste them right below because it's going to do the same exact thing from this one. Connect this up here. So now let's compile and save. And back in our BP fireball, let's delete out the sphere because we don't need that anymore. And then the collision capsule, let's just hide that because we already know that that's going to face in the correct direction. So we can say hidden in game, checked. Compile, save. We are ready to test this out. All right, moment of truth. And it's working. You know, it kind of reminds me of Harry Potter where they're casting spells with wands all around, just shooting, shooting, shooting. But you might notice if you're trying this out, if you're following along with me, that there are still a number of issues with this. And we're going to solve those one by one. But the very first thing that I think we should do is tie the intensity variable that we're passing into the BP fireball, actually tie that to both the intensity of the flame of the fireball, but also the speed of which it moves. So what we're going to do, just like our flamethrower effect episode, if you go back into content and into Niagara, and then the gameplay abilities fire and fireball, we are going to duplicate our NS Fire fireball base, and we're going to create one that's with user parameters. So right click, duplicate, and NS Fire fireball with UP. And we'll double click to go into that. And we can close out of our base fireball now. We won't need it again. And now, if you followed along in episode 27, I want you to go to content drawer, back to fire, back to flamethrower, and we're going to do the same thing. We're going to open up the fire flamethrower with UP. Because what we're going to do is you can literally copy and paste from one emitter to another, and it's a very fast way of putting in the same user parameters. So here's what I mean. So make sure you're in the fireball with UP. Make sure you're in the copy and not the original base one. What we're going to do is we're going to delete out these 3 spawn rate nodes. And I realize that that's kind of disconcerting, but trust me on this. So delete this one, and delete this one, and delete this one. So now there's nothing spawning, right? But if we come back over to our flamethrower with UP, this is kind of a nice trick. So we can select the one we're already using where it has a bool of our user parameter for spawn particles and a true float of intensity. So it's literally spawning based on the intensity we pass into the Niagara system. But we can copy that, right click, copy. Come back to our fireball with UP, and then right underneath the emitter state here, we can right click and paste. And you'll see as soon as you do that, those same 2 user parameters come in automatically. So we can just save the time of having to create them from scratch. Now go right back to flamethrower. We're going to do the same exact thing for the other 2 emitters. So copy, back to fireball, keeping all this stuff consistent. Select emitter state, right click, paste. And then back to the flamethrower one last time, spawn rate, copy, right back to fireball with UP. Spawn rate, and this one I guess I forgot to delete, huh? So this one, delete, and select spawn burst instantaneous, and then paste. Save that. So now we can close out of the flamethrower system. Let's go back into our third person character, because here we've got to adjust our primary Niagara system here. So I'm going to once again search for fireball, and then I'll pick the one with UP. And just for the sake of testing what we're about to do, make the intensity about 20 instead of 100. Compile and save. So now let's go back to our gameplay ability fire. And directly below the spawn actor BP fireball, so this is again what we did in episode 27 for the flamethrower episode. So we set those two user parameters, intensity and spawn particles, the moment that our flamethrower system spawned. So we could do the same thing here. And so we can copy both of these nodes, including the intensity here, copy those. And then I'll come up here to where we actually spawn the Niagara system. So yep, right here next to the montage, we spawn our Niagara system, and I'll paste them here. And then this is the Niagara system reference we have to hook up. And then I'll connect it up just like that. And so what this is doing is it's telling the system as soon as it spawns, okay, so the intensity that we fed in when we actually spawn the gameplay ability, then that's going to feed how many particles actually spawn in the Niagara system. All right, let's test this out. So 3, 3, 3, 3, 3. Yeah. And so now let's crank up the intensity to 100 or 200 and let's look at the effect. So back in our third person character blueprint, let's do, how about we do something crazy? How about 300? Compile and save. 3, 3, 3. Yeah, much more of a fireball, huh? The performance is pretty solid, so I'm looking at my frame rate up there, and we've got a bunch of fireballs in the scene, and I don't really see them dropping our performance at all, so it's a good sign for the future. All right, let's put this back to a regular intensity. 100 is good. Compile, save. So now let's set up the speed of our fireball to be based on the intensity that we pass in when we spawn our gameplay ability fire. So back in our gameplay ability fire blueprint, so we need to hook up that intensity variable here. So I can search for intensity, get, connect this up, and I'm also going to do the same thing down here. And the other thing I decided to do is hook up this instigator pin because it says instigator. That's the pawn responsible for damage and other gameplay events caused by this actor. And I don't know if this is going to be important when we start doing damage, but I figure it might be. So better to be safe than sorry. So I'm going to take our third person character reference, hook that up to instigator there, and then also over here. Compile and save. We'll go back to our BP fireball, come down a little bit, make some space over here. I'm going to delete out event actor begin overlap. We won't need that. And I'll drag these out a little bit. Now for the intensity here, I'm going to start by multiplying it by a factor of 10. So if the intensity is 100, then that's going to mean this is 1000. But then I'm going to add to it 2000. And so that means our base speed, like our base impulse, is always going to be this 2000. And then it gets added onto whatever the intensity times 10 is. So now let's compile and save, test it out again. All right, 3, 3, 3, yep, shooting out a lot faster now, which I really, really like. But one problem is if I do this very close to something, then the fire continues to be attached to the player's hand. So what's going on there? So this is actually working as designed because what's happening is as soon as the montage plays and then we have the event fire on our animation blueprint. Let me go back to our event graph. So the event that's firing, if I come down here, that's the activate main ability effect. So what's happening is it's doing a sphere trace up in front of the player. And then if it does get a hit, then it deactivates the ability. And the ability is getting deactivated without actually deactivating the Niagara system. So all we need to do is we need to go back to this event. So if I go to gameplay ability fire and I come down to deactivate, so that's down here. So what do we want to have happen when single cast is triggered here? So all I'm going to do is if I come up to where the Niagara system first gets spawned, so that's up here. So we have this set bool parameter spawn particles. So what I'm going to do is I'm just going to set that to false, and then it's going to stop spawning particles. We need to get a reference to our Niagara system and connect that up to the set bool parameter, and that's going to be connected to single cast right there. Compile, save, we'll test that out again. So what should happen here is that as soon as it starts the Anim Montage, as soon as it starts the movement, then the particles of the Niagara system start spawning. But when it gets the collision hit with this pillar right in front of the player, then the particles should stop spawning. Yep, and there we go. The other thing I'm noticing as I'm running around casting these fireballs is every time I cast one, it kind of pushes the player to the left. Sometimes it shoots them across the screen like you see there. And the reason that that's happening is that the collision capsule of the fireball is actually colliding with our player's collision capsule. So let's take care of that. So for that, we have to come back to our gameplay ability fire, and I'm going to go up to where we actually spawn the BP fireball actor here. And instead of giving it a spawn transform where it spawns right on our player's hand, and that's what's causing the collision with our actual player, what I'm going to do, if I drag out a pin here, I'm going to transform the location, and I'm going to move this a little bit out from the hand. So X is -150 and Y is 100. And then from this, I can make a new transform, so make transform. And that's going to be our location. And the rotation and the scale I'm keeping exactly the same. So I'll just connect this up here, connect this up there. Now I realize this is getting very messy. So let's make some space here. And I think this is the first thing I'm going to end up collapsing to a function this episode. But let's organize this here as best we can. So how's that? A little bit better? A little bit cleaner? Realize it's still not great. So we'll collapse it to a function at the end of the episode, and that way we won't have to worry too much about it. Compile and save. Let's test this out one more time. All right, so now throwing the fireball, and I'm not getting those collisions where it's pushing the player. And it still looks like it's being thrown directly from the player's hand, so it's looking good. So the next issue we're going to solve is the fact that as it currently stands, the fireball lasts forever. And the way we're going to address that is based on the intensity variable that gets passed in, we're going to have this intensity slowly decay over time. And as that intensity decreases, then the number of particles that are spawning in the fireball is also going to decrease with it. And when the intensity reaches 0, that's when the actor will destroy itself because there's no more particles, it ceases to exist. And so because we're going to need to dynamically update the Niagara system over time, we need to add a Niagara system to our BP fireball actor here. So I'm just going to search for Niagara up here, Niagara particle system component, and make sure it's underneath our collision capsule. But first I'm going to title it Fireball Niagara System, and then I'll move it under collision. Compile and save here. So now back in our gameplay ability fire, we have to come over to where we spawned our actors of the fireball. And before we actually attach them component to component, I need to set the Fireball Niagara System. If you scroll all the way down, set Fireball Niagara System, and I'm going to attach this up right here. And I'll add a reroute here just for organization. And what we're setting this to be is, you probably guessed it, the Niagara System one here. Because basically what we're doing is we're saying our Niagara System that's starting on the gameplay ability fire, that's going to become the Niagara System that's actually on BP Fireball. So then I can copy this, I can paste it down below because we're going to do the same thing down here. Make sure to connect this pin up to target, add another reroute. And then we also need to correct this over here, right? Because instead of attaching the Niagara System one here, it's going to be attached directly from our new variable. So I'll delete this out here, connect this up, and we can actually save some space here. I'm going to get rid of the reroute. I'm going to move this over here, do the same thing for the other one. So before we go any further, let's just compile, save. Let's test this out, make sure nothing's broken. 3, 3, 3, 3, 3. Awesome. All right, so now back in our BP Fireball, we're going to create a new custom event. And what this event is going to do is it's going to age the fireball. And the way I'm going to set this up is as soon as the fireball is spawned, so every 20th of a second, every 0.05 seconds, this event's going to get called and it's going to decrement. It's going to decrease the intensity variable. And that's going to feed back into our Niagara system. So we're going to start by getting our intensity, and then we're going to subtract 1, and then we're going to clamp this, clamp float. And the clamp is going to be a minimum of 0, and whatever the intensity is now will be the maximum. We never want this going below 0. And then from this, I'm going to set the intensity variable to be the new intensity. So basically, it's 1 less than what it was. And so now I can get the reference to our Fireball Niagara system, and I can set our float parameter. And that parameter we called intensity. And that intensity is going to be this one. And this is going to drive how many particles continue to be spawned in that Niagara system. The other thing I'm going to do here, and this is temporary, is I'm just going to do a print string. And we're going to look to see how many particles are actually being spawned at any moment in time. So from the string text, I'm going to append. And the first part is going to be new intensity. This is how many particles are actually being spawned. And the second part, if I drag an intensity, then I can connect that up here. And so now we're going to call this event using a mechanism you have not yet seen before in this series. And we're going to do so as soon as that fireball is created. So as soon as event begin play happens, and then the impulse gets added, and then we are going to set a timer by event. And we did timers before last episode, but this is a little different because we can tell the timer, okay, when that timer gets hit, trigger this event here. And for this timer, you heard me say, well, I want to call that event 20 times a second. So I'm going to set this to looping, and then the time is 0.05. So every 5/100ths of a second, then it's going to call this event. All right, let's test this out. Compile and save. And I just got to delete out the fireball actor I have here. Otherwise, it's going to fire like crazy. All right, here we go. Let's watch the top left corner, see how many particles we get. New intensity. Yep, 60, 40, 30, 20, 10. Perfect. And then the fireball disappears into the wild blue yonder up there. Gone. So back in our BP Fireball, so I'm going to delete all this, and now we have to set what to do to this actor when the intensity reaches 0. So to do that, I'm going to do a branch node, and the branch node is going to evaluate intensity. So if the intensity equals 0, and connect this up, then I'm just going to do a quick delay. So delay, and let's set it to about 1 second, and then we'll destroy the actor. Compile, save. One other issue fix I just want to mention really quick, and I haven't been able to reliably demonstrate this, but back in our gameplay ability fire, in case your montage gets interrupted, let's also say on interrupted and on blend out, let's do this anim notify and spell restore. And the reason is that in the future, when the player is spellcasting and let's say an enemy hits them or something, interrupts the ability, we want it to go back to its normal state. Compile and save this, and so now we're on to the last piece of this setup, and that's our Fireball audio. And for this, we're going to use 2 different audio files. We're going to have one sound playing when the fireball is actually charging up, and then we're going to have another that's continuously looping that's actually on the fireball as it's traveling through space. But even though it's continuously looping, the fact that the fireball is traveling is going to give it some variance, and also the fact that we're going to change the sound based on the total number of particles on the fireball at any given time. So let's get the sound that we're going to use for the charging up of the fireball, and we'll go from there. So we're going to use this free sound from Zapsplat, and as always, in the description below, you can find a link to a spreadsheet that contains all the free assets that we're using in this episode and in this series. So there's the sound we're getting. We're going to get it in MP3 format. And then what I do is I use Audacity to both convert the file to wave format, but also edit it a little bit. So we're going to drag in our Blast Wave FX. So the first thing I'm going to do here is I'm going to select it, and then Effect, we're going to change the speed. We need to make this about 20% faster. I can test that out. The next thing is this sound needs to be a lot shorter. So we're going to start it right after this spike right here. We're going to start it right about there. Actually a little bit. Yeah, right about there. Cut it. And then finally, I'm going to cut the end. So right about between this mark and the 0.8 seconds, we're going to cut that because we're going to have another sound that starts playing right around probably about this point, 0.3, and that's going to be with the fireball itself. So then I'll go to File, I'll export this as a wave, and I'm going to call this Fireball Cast 1. Save. So we are done in Audacity. I'll close out of this. So now back in the engine, if I navigate to my sound, gameplay abilities, fire, and this is a folder that we started back in episode 27 with the flamethrower, and we're actually going to use the audio that we set up in episode 27 for the fireball sound. And so if you want to see the details of that, just go to the very end of episode 27. But now what I'm going to do is I'm just going to drag in my fireball sound. Yeah, pretty loud. So we need to make a cue from this. So I'll right click, create cue, and it's going to be our Fireball Cast 1 cue. And I'll go into that. And the updates for this, so I'm going to make the volume multiplier just 0.5, so a lot quieter. And then for our attenuation, very similar to the flamethrower, I'm just going to use the footstep attenuation that we set up. I think it was episode 19 on footsteps. So footstep hard surface attenuation, just to show you what that looks like. If I go into that. So very small inner radius because the fireball is originating right around the hand, and then it tapers off at about 950. And I'm not doing spatialization for this because it's just being used by our character. Now, if you're going to have other characters casting this fireball, then you will want to enable spatialization. All right, so our cue's all set. We can exit out of that. And next, we're going to go into our gameplay ability fire because we are ready to get that sound up and running. So if I go back to my event graph, so what I'm going to do is back in episode 27, we set up a spawn sound attached here, which is for our flamethrower. And I can literally copy that entire segment, and I can paste that up with our channeled spell because our sound's going to start playing the moment that the montage begins playing. So I can just paste it right over here and then connect this up. So 2 things we have to change here. So first, of course, we've got our fireball sound cue, fireball cast 1 cue that we're going to use. And the other thing is our start time. So for this sound, we always want to start it at the beginning. So we're going to cut this out, compile and save. Now the question is, how are we going to change the volume and the pitch of this sound depending on where it is in the animation, right? Because we want the volume to scale up, well, quickly, but it still has to scale up from 0. And if you remember back in episode 27, so we set up this volume and pitch adjustment function based on intensity. And so basically that's getting an animation curve value, effect intensity, and that's multiplying it by how intense our actual spell effect is, the intensity here. And then it's setting a volume multiplier based on that. So the curve value, typically in an animation, it goes from 0, like before the sound is actually beginning, to however intense that sound needs to get. And so we're going to do the same thing, setting up curve value on our montage. So if I go back to the content drawer, we got to navigate to our characters, our mannequins, animations, Manny, Mixamo, into our montage. And so down here, once again, we have curves. So I'll go to curves and add a curve. Now, if you followed along in episode 27, then you don't need to create a new curve, and we could just search for effect, and it's the effect intensity curve. And I'll double click to go into that. And we need to add 3 keys to this curve because in effect, the sound starts at 0. And then right about, let's see if I can get it, like right about there, that's where we want the sound to peak, the casting sound. And then the casting sound is going to go down slowly to nothing when it gets to about here. So if we right click on the curve, I could say add a key, and we also got to do that for the very end, add key. And then right about where we want the peak sound to be for the casting. So right about, I think right about there actually. So I'm going to add a key. And this one, I'm going to change the value to be 1. And then I can zoom out with my mouse wheel just so I can see the full curve. And then we're going to auto tangent these keys. So right click and say auto. And this one too, right click and auto. And this one, right click auto. All right, so that curve's looking good. We can save this. We can exit out of the montage. And now we are ready to test this out. All right, here we go. 3. So far, so good. The only issue I'm seeing is that the sound sounds identical every single time, right? So I've got an easy fix for this. If we go back to sound, our gameplay abilities, fire, and into our fireball cast 1 cue, there's a really simple way to kind of vary up a sound every time it plays. And so I'm just going to make some space here. We can drag out a pin, search for a modulator node, and then connect the output here. And what the modulator does is it allows us to basically randomize our pitch and our volume a little bit. So the pitch I'm going to randomize between 0.8 and 1.2. And the volume I'm going to randomize between 0.9 and 1.1. Now I thought about tying the volume and the pitch to the total number of particles in the fireball spawn, and we could even do something with meta sounds where we pass that value into the meta sounds. So if you want to try out that setup, be my guest. But I found that just randomizing it simply gave it a really nice feel, and I figured just keep it as simple as possible. All right, let's test this out again. 3, 3. Yeah, so that just varies up the sound enough that it gives it some variability. But the very last thing is that the sound ends kind of abruptly, and really that fireball is going to have a sound as it travels through space. So let's set that up now. So we got to go back to our BP fireball. And for this, we're going to add in an audio component. So I can add audio, and we can add fireball cast 1 cue, but let's just make sure to call that fireball sound. And we will remove that cue here. And the other thing is make sure that the fireball sound audio component is a child component of the collision capsule, because we got to make sure when the collision capsule moves through space that it also moves the fireball sound audio. So now let's go back to our content drawer, and we're going to duplicate the flamethrower channel cue that we set up in episode 27. So we'll right click and duplicate, and this is going to be fireball 1 cue. And we're only going to make one change to this if I go into this. So we're going to switch out our attenuation asset. And the reason we're going to do that is because we're going to use a spatialized sound for this, because the fireball is inevitably going to be traveling through space. So let's go back to our content drawer. We'll right click here, and under sounds, we'll create a new sound attenuation. And I'll call this gameplay ability fire attenuation, because I'll probably end up using this for other things. So we'll double click into that. And I'm going to give this an inner radius that's pretty small, about 100. And we're going to make the fall off distance a little bit less, so about 2000. Still going to be kind of loud, but not that loud. And we'll keep enable spatialization checked, but just for the purposes of headphones, I'm going to switch this to binaural and then save. And we'll switch out what we have here with our new fire, gameplay ability fire attenuation, and save that. And so now let's get a really simple test up and running. So let's go over to BP Fireball. And the idea is that when the fireball is spawned, so event begin play is triggered, and it gets to this point, and let's play a sound at location. So we'll get a reference to our fireball sound, and I'll just say play. And just so that the start time's a little bit randomized, I'll drag out a pin, I'll do a random float in range, and we'll set this to be, let's say, 0.0 to 0.1 seconds. And the last thing is we have to actually give it our sound cue, right? So the sound here, let's search for our fireball, and it's going to be the fireball 1 cue. Compile and save. And let's test this out. You ready? 3. And I can hear the fireball kind of zippity-doo dying away. Yeah. If it bounces off of something right now, I can just hear it pretty close by, and it is spatialized. I hear it more on this side. But now what I want to do is I want to adjust the fireball sound over time, because you saw the fireball there just kind of disappear as the number of particles decreased. So wouldn't it be cool if the sound can slowly change based on the number of particles in the system that's attached to the fireball? So as the fireball is traveling through space, the number of particles spawning is going down. So the sound should also deepen and then diminish in volume a little bit. So the way we're going to do that is we're going to set a variable for the original intensity of the fireball. And then based on that original intensity, we can compare where its current intensity is at any moment in time and adjust the volume and the pitch accordingly. So under variables, we'll create a new one and I'll call it original intensity. And this is going to be a float. So that original intensity variable, that's going to be set just once at the end of begin play. And that's where we can drag in our intensity and set it directly. So then we're going to change the volume over time based on the difference between the original intensity and the intensity as it's slowly diminishing. So if we come up here to event tick, so we're going to need both our variables, our current intensity, but also our original intensity. And we need to divide these. So divide, and that's going to determine what our volume multiplier is going to be. So I'm going to clamp this between 0 and 1, so clamp float. And then I can get a reference to our fireball sound component, and I can set the volume multiplier. Connect this up and connect this up here and move this down. And now we're going to do the same thing with the pitch multiplier. It's just a little bit more complicated. So fireball sound, we'll do a pitch multiplier, set pitch multiplier, and connect this up. And I'm going to set this up backwards because I think it makes a little bit more sense. So the first thing is I never want the pitch to dip below, let's say 80%. So the minimum is going to be 0.8, max is 1. And so because I never want it to dip below 0.8, what I'm going to do is we're going to start it by adding 0.8 to some value. And I'll move these out a little bit, make some space. And what we're going to add it to, so first I'm going to get this over here, intensity divided by original intensity. But because the effect is going to be roughly 1/5 as strong as the volume, because this is varying between 0 and 1, but this is only going from 0.8 to 1, then what I'm going to do is I'm going to divide this by 5 and then connect this up here. So let's say intensity is down to 20% of the original intensity, right? So if it's 20% divided by 5, it's actually going to be 4% plus 0.8. So it'll be a pitch of 0.84. Compile, save, let's test this out. So the way I'm going to test this is I'm going to slam the fireball directly into the rock there, and we'll listen to it as it hopefully slowly moves away from me. Here we go. Well, I pushed it away, but I think you already heard that the pitch sound was decreasing and the volume much faster. The last optimization I want to do before we end the episode is in the volume and pitch adjustment based on intensity function that's part of our game playability fire blueprint. And we first set this up, I believe, in episode 27, the flamethrower episode. And what you might find in testing out the fireball sound is that very occasionally I was getting these is valid errors. Basically that the primary Niagara audio was not valid. And so to fix that, what I found works is if we just drag in a second reference to our primary Niagara audio, and we're first going to do an is valid check. And then only if it's valid, then it checks to see, okay, is it active? And then it finally does its volume and its pitch modification. But I also ran into another issue with the fireball sound. And that is the fact that at very low intensities, this part of the set volume multiplier function, this could be such a low value that I don't even hear any audio with the fireball casting at all. And so what I'm going to do is I'm going to diminish the effect that intensity has on the volume. So I'm going to set this to be intensity divided by 500, but then I'm going to add, so it's always going to be a minimum of 0.8. But that's still going to be multiplied times the effect intensity curve so that the overall effect is still ramped up. And so now all that's left is to clean up our setup. So let's go to BP Fireball. What I'm going to do is I'm going to collapse our set volume and pitch. I'm going to select all that and then collapse to function. And I'm going to title this Adjust Pitch and Volume Based on Intensity. Compile, save. I'm also going to make some updates to our gameplay ability blueprints. So if we go back to the gameplay ability fire event graph, and then come down here to activate primary fire Niagara System. So I want to change the name of this event to better reflect what it's doing. Because for some of our gameplay abilities, the Niagara System is actually activating immediately as soon as that gameplay ability is activated. And that's the case for the fireball. So I feel like this name is not an accurate representation of what it's actually doing. And so up further, we have activate ability. But for this, what I want to do is I want to right click, rename, and I'm going to call it activate primary fire ability effect. And then compile and save. And we're going to do the same thing on our main gameplay ability blueprint. So if you go back to blueprints, gameplay abilities into here, And instead of calling this Activate Primary Niagara System, right click and we'll rename, and I'll title this Activate Primary Ability Effect. So the only difference is this is just generic primary ability effect, and the other one is specific to fire. And compile and save both of these. And you'll see that also in the gameplay ability blueprint, it automatically adjusted it here. So let's go back to our gameplay ability fire blueprint. And this is starting to get messy. We have a bunch of events, and I'll start collapsing some of this stuff to functions, but really the messiest one is what we're doing right up here. Spawn actor, BP fireball, all this stuff. Got to collapse all that to a function. So I'll select all this, and I'm going to right click and collapse to function. And that way I can get rid of the reroute node here. Can just move this right there. And I'll right click on the function. We're going to rename this to be Activate Effect Single Cast. Activate Effect Single Cast. And then down below it, I realize this is not nearly as bad, but let's do the same thing. So I'll select all that, right click, collapse to function, and I'll go to rename, and then I'll call this one Activate Effect Channel. And the last piece of cleanup that we're doing this episode is something that's generally useful, so it's not specific to this episode. But back in episode 26, when we first set up our gameplay ability system, what I did is I said on event begin play, we're going to set up our references back to our third person character. And what these are doing is they're calling functions that we set up on the original gameplay ability actor here. But there's a faster and cleaner way of doing this, and I want to thank the person who pointed this out in the comments on episode 26. So if we go back to our gameplay ability fire, and I can delete these out, and instead of calling the functions directly, what we can do is we can right click and we can say add call to the parent function. And what this is going to do, if I hook this up, all it's doing is it's saying, okay, call this same event on whatever the parent actor is. So basically it's calling event begin play, but on our gameplay ability here. The last thing I want to mention here is an issue I ran into, and quite frankly, I don't know how to solve it, so I could use your advice and input in the comments below. And also, if you want to join the Discord, we meet every Friday from 6 to 7 p.m. Eastern Time. But here's the issue. So I hit 3. So the issue is related to these volumetric cloud actors that you see in the background there. And I tried playing with a bunch of different settings like the translucency and sort priority and all that stuff, and nothing seemed to work. And even stranger, I only had this problem when I was in a specific part of my level here. I don't think it's related to the specific Niagara system because I found the same problem when I had the torchlight effect, which is a completely different Niagara system. And specifically what's causing this is the layer height. So if I make this very thin, like if I make it a 1, let's do like a 2 or something like that. And then I'll show you. So now when I do it, you notice that some of the effect is actually shining through. Not a lot, but if I lower that layer height even more, then it's going to completely shine through. And I really like these volumetric clouds. I bet there's an easy fix out there, so once again, asking for your help. So that brings us to the end of our episode, but we're left with a problem because obviously we don't want all these fireball actors just bouncing around. So that's exactly what we'll address in our next episode. Fully equipped with dynamic burn decals, and I hope to see you there.